Alright, my name is Christopher. You're welcome to the Chem Lab Chemistry Lecture. Today I'm going to be talking about gas law, and our focus today will be on Charles law. The other time we looked at Boyle's law, so today we're going to be looking at Charles law. Now, Charles law states that the volume of a given mass of gas is directly proportional to its temperature, provided that pressure remains constant. So mathematically we can express it as V directly proportional to T. And then introducing the constant of proportionality, we now have V equal to KT. Now let's make K the subject of the formula. In making K the subject of the formula, we have K equal to V over T. Now, with this, it simply means that K is equal to V over T. Therefore, I can substitute V over T for K in this particular equation. So we now have V over T equal to what? V over T. Now, this V is different from this V, and this T is different from this T. Now, to differentiate them, we have V1, T1, V2, T2. So that's how we differentiate them. Now, it means that this V1 is the original volume, but by the time temperature change, a new volume is actually formed, which is the V2, and then the temperature that it was changed to is now the T2. So this is a mathematical expression of Charles law. Now let's look at a question under Charles law to actually prove the validity of Charles law. Now, before we continue, you must take note of this. Let's put it this way. The temperature in this case is not expressed in degrees Celsius. No. It's expressed in Kelvin. So Charles law can also be stated as the volume of a given mass of gas is directly proportional to its temperature in Kelvin, provided that pressure remains constant. So it means that if in a question you are given temperature in degrees Celsius, you would have to convert it to Kelvin before you can use that particular value that was given to you for the temperature to calculate for whatever it is you are looking for in Charles law. Now, how do we change from degrees Celsius to Kelvin? It's pretty simple. Now the formula is degree Celsius plus 273. So Kelvin, to change degree Celsius to Kelvin, is K equal to degree Celsius, that is the value they give to you in degree Celsius, you add it to 273. Now whatever you get, that is the value of that degree Celsius in Kelvin. Now let's look at a particular question to actually illustrate this properly. Worked example 1. At 17 degrees Celsius, a sample of hydrogen gas occupies 125 cm3. What will be its volume at 100 degrees Celsius if the pressure remains constant? So it's a question Now we have 17 degrees Celsius, that's T1. 17 degrees Celsius. We have the sample of hydrogen gas occupies 125 cm3. So V1, 125 cm3. And then we have T2, 100 degrees Celsius. And V2 is what we have to look for. What will be its volume at T2, 100 degrees Celsius. So we said from the other time that we need to convert to what? Kelvin first before we can use the word temperature that is given to us. So here we now have, that's degrees Celsius plus 273. So we have the degree Celsius value here is 17. So we have 17 plus 273, which will give us what? That should give us, we have 10, then 8, 9. So that's 290 what? Kelvin. So we have converted T1, 17 degrees Celsius to what? Kelvin. It's now 290. Then let's convert 100. So we have 100 plus 273, which is what? 373 Kelvin. So before we start solving, we have to convert it first. So we have succeeded in what? Converting it. Now let's bring in our formula. We have V1 over T1 equal to V2 over what? T2. So we have V1 over T1 equal to what? V2 over T2. Now usually we already know what we are looking for. So normally I would have just said let's make V2 the subject of the formula and then solve. But let's just include the value. So V1 is what? 125 over T1 is what? 290 equal to V2 is what we're asked to look for over T2 is what? 373. So at this point we cross multiply and then we have 290 V2 because cross multiplication means we are timesing equal to 125 times 373. Now at this point, remember we're looking for V2, so we divide both sides by what? 290. So we have V2 equal to 125 times 373 over 290. Here is assumed that we have divided here by 290. So 290 cancel 290, we have V2 left. So V2 is equal to 125 times 373 over what? 290. Now, at this point, you multiply these two. Whatever answer you get, you divide it by 290. That will give you the answer for what? V2. So we have gotten our answer for what? V2. I believe that is clear.